Missed an episode of your favorite podcast? Choose from over a decade of content in our archives, not just the latest episode. All free at GCNlive.com.
This is your call to action. Get prepared, America. Economy, survival, energy, disasters. This is USAPrepares.com. Informative radio, educational radio. Interact now by emailing instructor@USAPrepares.com or text at 434-390-7953. Class, please take your seats. Now, your instructor, Vincent Finelli.
What a great day. What a great day. Everyone all set, cocked, locked? Here we go. Your dial set correctly to USA Prepares. Thank you so much for being in class. John is engineering the broadcast at GCN in Minnesota. I'm Vincent Finelli. Oh, and if you'd like to call us, we'll pay for the call, 866-582-9933, 866-582-9933. And you might want to write this down, telephone listen line, in case the internet goes down, 605-477-3249, 605-477-3249. Put that on your refrigerator. Great day. It's Captain John Regan with us. Welcome, Captain John Regan.
Good morning, Vincent.
Hey. That's class. That's an inside joke. I would call Captain John Regan. He'd say hello. I'd say, hey. Is it Monday yet? And what he meant by that is, are we going on there? Do you need me to get ready for broadcast? Hey, that's what that meant. And Captain, it's your anniversary. Very special day. 7 years. 7 whole years of pure bliss.
I think you needed a 55-gallon drum of bliss over the last 7 years.
You're talking about the world turning upside down, inside out, left is right, wrong is now right, it's twisted. Is that what you're talking about?
Well, that was 7 years ago today that you first invited me onto USA Prepares, and for some reason you kept on inviting me back.
John Regan, I just love broadcasting with you, and I'm so glad we are close friends. I really mean that. You bring such a wealth of information to the broadcast classroom. You really do. Your research is superb, and I know, Captain John Regan, you've got. Well, let me just read a couple of these titles to whet the appetite of our class today. So, class, if you'd like to follow along with us, you can go to thefinancialstateoftheunion.com. And the first thing I think we're going to be talking about is the St. Valentine's Day Retail Massacre. Then the lies have it. That's Lies. The lies have it. And then we're going to talk about poor Chicago. And where do you want to start? Do you want to start with St. Valentine's Day?
I don't know. Maybe we ought to follow up a little bit of what you talked about. The last 7 years have been for everybody. And it's been somewhat frustrating, I know, for you and me both, just trying to get people to wake up to what's going on and take some action. And it's really difficult because we tend to have this perception of history that's only during our lifetime. And even for that, sometimes people don't even have a good, grasp of reality. But if you look at where we are now, somebody that's 55 years old, which means they were eligible for AARP 5 years ago, these people are too young to remember the last time we had real money in circulation. And that was the silver coins and the silver certificates. LBJ got rid of those back in the 60s. You look at 70 years ago, that was after World War II. So a 70-year-old has, no reference in their lifetime of the austerity of the Great Depression and World War II. 80 years ago, it was 1939. That was considered the end of the Depression. And even if you were born in 1939, probably your earliest memories are 1942. The war was over in 1945, so at best you've got young childhood memories of World War II. And I realized just a couple of years ago, I made a mistake of comparing what we're getting ready to experience to the Great Depression when most people have absolutely no reference to it. They might have read about it, in a history class, but without any real context, I think they just think it's, a little bit worse than a recession. And it's not. It's much deeper than that. And unfortunately, many millions of us just in America are going to experience that soon. And now we'll see some of the earlier signs of that just in what I've got lined up for today. Vincent?
You mentioned the LBJ and silver. Yesterday, we had the pleasure of having a young lady stop by at the farm, and she graduated in 2018 from the university. And so we gave her a 2018 American Silver Eagle. And we said she had a part-time job as a teller in the bank, and I asked her what money was. And she actually said silver. She had a job at a bank, and I couldn't believe it. She's the only person who worked at a bank that said that money is silver, rather than dead presidents on, pieces of paper with, green and black ink. But she was right. And the reason we gave her 2018 was that that's the year she graduated. And I said that, you can keep this for a long time, or if you need money, if you need currency, you can exchange this real money for currency and buy something, in the future. But it will probably keep going up and up and up in value over time, slowly, until it takes off. Then it'll go quickly. But the important thing was that it was silver, and the important thing that it was U.S., and the important thing that it had the year of her graduation. So that's the kind of thing that we do, rather than buy, trinkets that end up in the landfill, because the trinkets are typically made in China. So just a thought. But you and I are on the same page, exactly. And looking over history. And by the way, I taught probably a 20-minute lesson on money, mini-max, regret, Max's law. And that's one of the problems. When people come over here, if they're young people, there's no way they're going to get out without a class. There's no way. It's a class on something, either automotive technology. Hey, let me show you this about your car. How things work, things that they were not taught in school. And at the end of that 20-minute class, I asked her if she learned things that she did not learn in school. And the answer was absolutely. A whole bunch of things that they didn't teach her in school. So she's a recent graduate. Just a few months ago. I just wanted to share that with you. You and I are on the same page at the same time, Captain John Regan.
Well, the cracks are really starting to show. And I've been noticing retail, having some problems. We're seeing more store closures and all of that. And we had a news article come out. Let me see the date on it. And of course, the computer's not cooperating. Came out on Valentine's Day, as a matter of fact. U.S. retail sales collapse in December, biggest drop in a decade. That's the first link I have in my Valentine's Day retail massacre post. And if you look at the chart in that, the drop month over month beat out everything from, the 2008 disaster. It goes back to 2001 with, the dot-com crash. That's how bad the retail sales drop in December was. But that doesn't tell us what's currently going on. And I had a personal experience right before Valentine's Day that makes me believe that things are even worse now. Like many of you, I buy from, the Chinese factory outlet, otherwise known as Walmart, and the big gorilla on the internet known as Amazon. Well, I placed an order with Walmart to be delivered to the store. So you get free pickup that way. And it was just like 3 items, but one of them had to be ordered from a different supplier. So there were 2 different delivery dates, and it was going to be delivered on a Tuesday and a Thursday, which that Thursday was Valentine's Day. Well, that's, kind of normal for doing those types of orders. So I also placed an order that weekend with Amazon, and I decided I'd have that delivered to a locker, which they have in Metroplexes. And instead of getting the free 2-day delivery that I'm entitled to with Prime, I chose the free 4-day delivery so that I could, just combine my errands to go out and collect these items. Well, the Amazon item was delivered the next day. And, I was nowhere near the order amount for getting free next day delivery, much less, I said, please deliver it 4 days from now, and they deliver it 3 days early. Then I get notified that my Walmart order is in a day early, which also happened with the one that was due Thursday, and we'll pick up the rest of the story after the break.
Captain John Regan's with us. And retail doesn't look all that good. And if you look at Payless, the shoe store, 2,500 stores closing. No kidding. We'll be right back. Captain John Regan's with us, U.S. Air Force Reserve's retired. Website, thefinancialstateoftheunion.com. If you'd like to follow along with us, please click on the news tab. Captain John Regan, you were telling us about an order from the Chinese factory outlet and Amazon. Please continue.
Well, I made another order from Walmart, and this was enough to where I could get free 2-day shipping to my door. And rather than make another trip to Walmart in the same week, I chose that option. And surprise, 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 it shows up the next day. One incident like this, that could happen. But to have this happen with 3 orders in 4 parts with 2 different companies tells me that things aren't that great out there, because these companies, both of them have fantastic, expensive computer systems that prioritize these orders so that the ones that aren't due immediately, don't get picked first. And, especially with this Amazon order, 4 days out and it gets there the next day. I've had the free 2-day shipping take 3 days with Amazon before. I've never had it come early. So not only did they have to get it through their inventory system and packed and delivered to, the logistics channel, for them, the logistics channel had to have the capacity. And these, weren't, express order, pay extra for overnight delivery type things. These were regularly, scheduled delivery type, packages.
I've got a comment, John. In Lebanon, Missouri, which is 20 miles, 25 miles maybe from our farm, and Springfield, which is about 50, 60 miles, depending on where you're going. The tax rates, sales tax rates are about 8% or a little over 8%. In our little hamlet, it's about 6%. So I found out that if I use our little village zip code and order on the Chinese factory outlet, Walmart's website, I don't pay the 8% as if I showed up at the store and picked it up. I'd pay 6% sales tax. And they have free shipping on over $35. I did something I couldn't believe. I bought engine oil. Now I'm talking about gallons of motor oil or engine oil. And it was shipped free at a lower tax rate than if I went to the store. But not only is it at a lower tax rate, they seem to put these liquids in plastic bags, very heavy, expensive plastic bags. So each gallon is in its own plastic bag, and then they put it in a heavy cardboard box. I really like these boxes for other purposes. I really like the bags for other purposes. I like saving 2% on taxes, and I like having it delivered. So it costs me less to have all that done than if I went there in person and pushed that cart around. And how long did it take? Just like you said, next day. How's that possible? And it's happening more and more. And here's what I learned, John. I was at a get-together where some preparedness-minded people were invited. And we were talking about things that were happening and things that we saw. And one of the people who was there was a female truck driver. And she was saying that what's happening is they are parking tractor trailers, the trailer part, behind these stores, storing the merchandise that they did not sell. They don't know where to put it. So they've got it. They've got a glut of it. And they are so thankful that you placed your order and that we placed our order. They can't wait to sell the stuff because they're choking on it. True story. Does that jive with what you're saying? I think it does.
Yeah, absolutely. And it's really insane. I love going in, doing the pickup where I don't have to walk the store, but that costs them money. These boxes cost money. The shipping costs money. It's absolutely crazy.
Yeah, it is. I'll tell you something else that I bought when we come back after these few short announcements. I mean, I'm very surprised that they'd even ship these things. We'll be right back. Captain John Regan's with us. And so what happened to me, John, is I wanted to buy some Fast Orange. Fast Orange is a hand cleaner. We use it because we want to get the grease off our hands from working on the farm equipment and automotive equipment, things like that. So we use quite a bit of it. And it at True Value Hardware, it's $16.99 a gallon, $17 a gallon. But if you buy it online at Walmart, you could get a half a gallon for $4.97. So if I bought 7 of them, it would be $34.79. But they've got a $35 minimum for free shipping. So if I have it shipped free, I can purchase it at a lower sales tax rate because our sales tax rate is 6% rather than the 8% at the Walmart stores around us. So I ordered 8 of them, and it was $39.76, which is a little bit more expensive than that's 4 gallons, because I ordered them in half-gallon pump containers. So now I have these half gallons that fit better on the kitchen counter. And I have 8 of these with 8 pumps, 8 jugs, shipped for probably less than I could have shipped an empty box that weighed as much as these 4 gallons or 8 half gallons of Fast Orange. What I'm saying is if I just shipped that weight, it would have cost me more to ship an empty box that weighed as much as this Fast Orange in the box, Wade. I can't believe how they're doing it. It can't possibly work in the long run.
Yep, and free Medicare for all, too.
Yeah. Yeah.
Well, before we run out of time, I want to get down to the lies have it. And I'll just reflect a little bit. I know I took advantage of the library in my high school, but if whatever books I checked out, I only remember the title to one, and that is How to Lie with Statistics. I mean, it's leave it to a math person to check that one out. And here we are, decades later, and I've occasionally talked about the employment report that the Bureau of Labor Statistics puts out. It's the first Friday of the month. And the numbers are typically so bad. I put the link up when I was on Weekly and not necessarily even talk about it. But this last one, just in case you think things have gotten better with Trump and reporting what's actually out there. And I've linked the report. It's a PDF, and I'm in my post. I say what page to look at, so you don't have to work too hard. If you remember the announcement, which was reported during the State of the Union, 304,000 new jobs. Isn't that great? Now, they did revise the December job growth, went down a little bit, only 222,000 jobs. But that's still 526,000 new jobs in November and December. Isn't that wonderful, Vincent? Economy is just great.
It's roaring.
Those are the seasonally adjusted numbers, and I don't want to take the time to explain seasonally adjusted. I do that a bit in the post. But in the real world where we live, we don't have seasonally adjusted numbers. We have what happens in real life. And these are reported as well. And for the non-seasonally adjusted data, the number of employed in November, 151,375,000. December's 151,182. January's 148,201. So to put that in the terms that they are, doing the math for you, that means in December we lost 193,000 jobs. And you better sit down, because in January we lost 2,981,000 jobs. For those 2 months, that's a job loss of nearly 3.2 million people. And during the break, I looked it up. We have 21 states that don't even have 3.2 million people in them. That's how big this number is. So instead of more than 500,000 gain, it's a 3.2 million loss. So they're only off by 3.7 million. I guess for the government, that's close. So
we are being lied to by the old media all the time, nonstop. They spin it. And what is a spin? Isn't a spin a more politically correct term for a lie? Don't police departments have spin people, public relations people, public communications people? Those are the spin doctors. Those are the guys who try to figure out how they can lie with statistics. And I did see that book, and I did peruse the book that you're talking about, How to Lie with Statistics. And if I'm not mistaken, that was published in the 1950s, and it was a big seller on to college students. How to Lie with Statistics. A guy named Huff wrote that, right?
I believe so. And just to finish up there, we'd had the government shut down for December and January, and a lot of you thinking, well, that had to be a large amount of the job loss. Well, the PDF also breaks this down to include government jobs, and you can look how many or what the employment levels were for the federal government. So in the report, the real numbers, not the seasonally adjusted numbers, had a job loss of 4,500 jobs for December and 3,900 jobs for January. So that's less than 9,000 jobs out of the 3.2 million that were lost. So no, the government shutdown didn't account for this amount of job loss. So, and just put more of the political spin on this, it really makes you wonder what's going on, because the Democrats just hate Trump. Most of the Republicans in Congress do too, I think. Why aren't they pointing this out to make Trump look bad? Of course, if they did that, then people would be aware of the lies that are in the reports that have been going back for years. And I only started looking at it during the Obama years. And I'm sure it was horribly, misstated before that. But anyway, like I say, the lies have it.
Yeah, I just looked up how long it takes to get a job today. In 2017, there's a post on the internet that says it takes 84 days to get a job in America. 84 days. Captain John Regan, I don't think the average person could survive 84 days if he had a mortgage payment and a car payment and, credit card payments and all that. Do you?
Well, maybe if you're young and lucky, you might get away with 84 days. If you're over 50, like I was when I was laid off, it has now been over 9 years. I'll tell you, it's no fun.
John, if I went to apply for a job, you know me pretty well, how long do you think it would take me to get a job? I'm being serious. Never?
That's pretty close to it. If you find a job that is just one of those that uses people, you might be able to get that, sales jobs, collection jobs, greeter jobs. But anything that, somebody with a college degree, like either one of us has, and this is even happening to younger people, but if you're over 50 and you lose your job, there is a darn good chance you won't ever find another one.
I was talking to some people about what it's like applying for jobs. I'm talking about young people, as you mentioned. And it's not the same process that we had. We would go in person, fill out the application. Somebody would talk to us. Maybe they'd interview us right then and there. And that's happened to me many times. They'd look at the resume or the experience profile or the vitae, and they'd get back to us. Today, it's you apply online, and you take a test online, and then if you pass that test, you take the second level test. And if you pass that test, you take the third level test. Then you talk to like a pre-interviewer that asks you more questions. And then you talk to another person. Then they have a committee meeting, and then they may get back to you.
Yeah.
I forgot the drug test. The drug test. Then you take, if they really think that there's a slight possibility that they may hire you, then you have to go for a drug test.
Yeah, and with a company of any size nowadays, when they get your resume in the application, it's the computer that decides whether you go any further.
Mm-hmm. Mm-hmm. And when I was chatting with this young lady who was here at the farm yesterday, teaching her all kinds of things that she didn't learn, I talked about Facebook, and I said, so if you're, at that pub and you've got that margarita glass in your hand, and you're raising it, and you got this big grin on your face, and you happen to be underage, and you are in an interview later on for a job, and the interviewer says, "Hey, weren't you underage in this picture?" What are you going to do? Don't put that stuff on Facebook. It's like the kiss of death. Don't do it. Captain John Regan, I'll be right back. Boy, John, our anniversary is going fast. Wow. So, class, if you've been to the Get Prepared Expo, you've met Captain John Regan. His website, thefinancialstateoftheunion.com. Please click on the news tab, and you can find the resources that John is talking about today. Poor Chicago?
Well, if you remember about 3 weeks ago, Chicago was colder than Antarctica, and that was bad enough for them. But coincidentally, Chicago bases, another coincidence, Truth in Accounting, the organization, released their latest financial state of the cities report. And in this report, 63 of America's top 75 cities are broke. Chicago came in number 2. New York City was number 1. 8 cities in total got a grade of F, and Dallas happens to be number 6 on that list. Well, you think that's bad enough, Chicago being number 2 as broke a city. Well, Truth in Accounting also releases a report on states. Well, Illinois is number 3. The only states in a worse position are Massachusetts and Kentucky. And when you combine how bad it is in Chicago with how bad it is for Illinois, that makes Chicago the brokest city in America, with almost $86,000 per person needed just to set things right again. Congratulations, Chicago. And I'm thinking about doing a follow-up to this, calling Dallas is doomed. It's like I said, Dallas is in the worst shape of any city in Texas, number 6 in the nation. I think it was last week, the Dallas City Council voted nearly $500,000 for the very important job of removing a Confederate monument from downtown. Vincent?
$500,000? Did you say $500,000?
Nearly $500,000, $500,000.
Are they going to use an atom smasher? I mean, what? Really? $500,000? Do you think somebody is politically connected to that job? Did they take bids? How big is this?
It is pretty good size. It's by the convention center, and I believe there's actually multiple statues there. So the entire monument they want to remove because it's not politically correct, of course. And it's kind of ironic. It's the Democrats today not liking the Democrats of yesteryear.
I'm wondering if it cost that much to make the World Trade Center towers disappear on 9/11. I'll bet you that didn't cost $500,000 to use that directed energy weapon. Jeez, this is, and what is the purpose of this? To remove history? Is that what this is?
Well, they have those slave-owning Democrats that they have monuments to, and we just can't have that in America today.
Mm-hmm. Did you hear about the statue of Lee that was desecrated, set on fire because some arsonists thought that was a Confederate Lee, but happened to be a World War II soldier in World War II uniform whose last name was also Lee. They burned the wrong statue. Of course, it didn't burn because it was made out of stone. But did you read that article?
I saw that, and they probably vote too.
That's the problem. That's the problem. That these people have a voice. These idiots have a voice. And it wouldn't be so bad if they were idiots and they wanted to improve their lot in life and they wanted to be productive. But I'm not seeing so much of that. I'm just seeing more and more stupid people everywhere I go. And unfortunately, they're causing a lot of damage in their wake by their stupidity. Class, just go to YouTube and type in idiot drivers, and you'll see what I'm talking about. I'll put a post on there on the website about that. Captain John Regan, thank you so much for sharing with us your wealth of knowledge. I'm delighted to be broadcasting with my dear friend, Lou Cassidy. Class, Lou Cassidy is an electrical and electronic engineer. And he's been to the farm, he's been to the expos, he's a dear friend of Dr. Norman Shealy and Dr. Sergey Sorin. And we're going to talk about electronics today. We're going to talk about some of the things that we learned, might have happened, things that we've done ourselves, experimentation that we've done over the years, and what's happened. Welcome, Lou Cassidy.
Good morning, Vincent.
So, I'm going to try to be careful how I do this. Oh, jeez. Lou, I used to love going to the mailbox when I was growing up back in the 1950s and the 1960s, and every month there'd be a new issue. And those issues that I just loved had the names Electronics Illustrated, Popular Science, Popular Electronics, and Mechanics Illustrated. I just love them. And where are they? What happened? Those were magazines that helped us do really cool things back then. You could learn how circuits worked. You could learn about electricity at a fundamental level and then build on it from there. Did you have that same kind of experience?
Oh, yeah. Popular Electronics and Electronics Illustrated were my big two, and I learned everything I know from this.
So are you saying that a person who was really interested could have given himself a degree in electrical engineering by starting with Popular Electronics, Electronics Illustrated, building these circuits, experimentation, learning, measuring, voltage, amps, milliamps, millivolts, those kinds of things? That's
correct, yeah. I virtually gave myself a degree through Popular Electronics, Electronics Illustrated back in the 1960s. We started off with vacuum tube circuits, and, you had to have the B+, the high voltage supply, and, you got shocked quite a few times playing with that stuff. And then we went to transistors, and it was nice low voltage stuff that didn't bite,
Yeah. Yeah, I remember making a vacuum tube amplifier because I was interested in high fidelity sound reproduction. And so I built a vacuum tube amplifier, nice mellow sound. I built a speaker enclosure. I experimented with tuned port cabinets, ducted port cabinets, periodic designs, and bigger boxes, smaller boxes. What impact that had on and what I perceived as the quality of the sound reproduction. So yeah, I got my start with vacuum tubes as well, and quickly it moved. That was the turning point away from vacuum tubes toward solid state, which would be transistors. So what was the main advantage of transistors over vacuum tubes, Lou Cassidy?
Well, the main advantage was the working on the lower voltages. You didn't have to have a big, hairy power supply. The transistors were a lot easier to work with. They were smaller. They didn't generate a bunch of heat, use a bunch of power. It was all much lower powered type of equipment made with transistors.
And then the next thing that happened was, well, there was a commercial. Let's start with this. And it was for Zenith televisions. And these were black and white and color televisions back in the 1960s. And they would say the quality goes in before the name goes on. And they would show these hand-wired televisions. And they would show the circuitry. And the connections were made with pieces of wire that had insulation on them, and they were stripped. And they were soldered from point to point to point. The capacitors, the resistors, the tube sockets, the transformers, all these leads were soldered in place. And it was like an army of assemblers that soldered all these connections. But then there was a revolution that took place, and that was the printed circuit board, right?
Oh, yeah. And the Japanese became very proficient at that very quickly. They would have these transistor radios with, a circuit board, and we call it Jap loading, is when you take a resistor or other components and load them vertically instead of horizontally on a board. And these transistor radios were just loaded with all these components on a little bitty circuit board. And most of those in that day were single-sided boards. I mean, you don't see that anymore. Now they're all double-sided or four-layer circuit boards. And back in the days of the TV and the vacuum tubes, they did. They went through a big, long assembly line, and one lady would solder on a piece of wire, this long, and another one a piece of wire a little longer on the terminal strips and on the lugs on the vacuum tube bases. And that was a monster doing that. And then they went to the printed circuit boards, and they hand-loaded those. And, of course, they've evolved now to where they have pick-and-place machines that parts surface mount, SMD, surface mount technology, comes on these big reels, 4,000 or 5,000 components on a reel. And these reels are loaded onto pick-and-place machines. And those machines are all computer CNC-type machines that move the board horizontally, vertically. The pick-and-place machine has a little tiny, tiny suction cup that grabs a component, orients it correctly, sticks it on the board that's already had a solder paste put on there. And, it's amazing to watch it. It's just ching, 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 back and forth and round and putting all these components on the board. And then they go through a reflow oven that takes the components and heats everything up to the melting point of the solder. And the components, if you watch them, they kind of center themselves on there, solder themselves onto the board. When it comes out of the reflow oven, it goes into another station that is an optical inspection machine that looks at every solder joint, every connection on there. Coming from the wiring TVs on an aluminum chassis with tubes to this, this is just a whole new world. It's eons beyond what we're doing back in the 50s. You remember all that stuff?
Oh, absolutely, absolutely. And when we were building satellite communications equipment in California back in 1980, our prototypes were all hand soldered. We would hand etch each one of our circuit boards, and we would experiment with what we thought was the best design, and ultimately then we would have that design mass produced. And the term that we used, and maybe it's not the right term, but once the components were placed on that circuit board for us, they would then go through a wave soldering machine. So this was a machine that had molten solder in it. There would be an application of flux to clean the board and the component leads, and then the board would be moved over this wave of solder, molten solder. The solder would attach to the board and the device leads,
yeah.
And that's how it was soldered. So you're talking about that kind of a machine, right?
The pick-and-place machines are completely different, but the wave soldering machines were for the through-hole components,
right,
through-hole technology where the resistor leads, the capacitors, transistors, all stuck through the circuit board. Even the early integrated circuits, 14, 16, 24-pin ICs were placed in holes in the board, and actually a wave soldering machine, it would go over the wave soldering station after the components were placed. And the wave soldering machine it was like the waves on the ocean coming in, little tips of solder that would reach up and splash on the board and heat it up and solder it and make good connections and all that stuff. And then they went to the surface mount technology, and the components are placed on one side of the board. There are no holes in the board, only pads. And these pads are layered with a solder flux paste from another station on the pick and place machine that'll put the paste right there where the component goes, and then the pick and place puts the component on there. And when all that's assembled, then they go through the but the reflow oven, and it heats everything up and solders them on there. And take for instance our chakra sweep with Dr. Shealy. I used to build those boards by hand and hand solder all the surface mount and all that stuff. Now I got a company in St. Louis that has pick and place, and they just finished a batch of them for me. And I actually got to see the thing in process working and soldering these boards. And our units have both surface mount technology and through-hole technology. So once it comes out of the surface mount, the pick and place and the reflow, it is a completed circuit board for the surface mount stuff. And then we have through-hole parts that go on, and that's another operation. It goes through, and at this time they're doing those by hand. There's so few through-hole components on there that they got gals that are that lay the components on the board and hand solder them and go through that station. And it's amazing how the technology has moved. And I've followed it all the way back from, like you said, the 1950s. Where Guineith, the quality goes in before the name goes on, and they showed all that stuff all the way through to the early single-sided circuit boards with through-hole mounted by hand, and through the new through-hole machines that were like the pick and place that would actually insert mechanically through the holes and then go through a wave soldering and all the way through to the surface mount stuff. And we're even going beyond that by putting all these components that we're putting on these boards are all going on the chips. The new microcontrollers are basically...
Hold that thought. We're going into a break. Lou Cassidy's with us. Lou Cassidy's with us, and we're talking about the good old days back in the 1950s and 60s and 70s in the electronics world where you could build things. You could build an amplifier. You could build a ham radio transmitter. You could work with antennas. You could learn, you could study, and you could actually fabricate your own devices. We're talking about how we went from vacuum tubes and resistors and capacitors and chokes and sockets and terminal strips and wire to the point where we replaced the vacuum tubes with transistors, but we still had some wire. And then we replaced the wire with printed circuits, and then we had one level single-sided printed circuit boards, and then we went to multiple layers within a printed circuit board. And now we even have an entire, and I don't know what you'd call it, but if we said that you took all those devices and you make an amplifier, you could actually have that amplifier in one package, except all you needed was a power supply and a heat sink and connections, to your speakers and volume control and that kind of thing. But you could have an entire amplifier in one little blob that was already made, and all you need to do is attach a few leads to it. Isn't that right?
They're doing now is putting all of those components that were on a circuit board onto one chip, anywhere from the size of your little finger to your thumbnail to maybe even up to the size of a silver dollar if you squared that off.
Right. And Lou, let me ask you this. this is my understanding, and correct me if I don't have this right. But we started out with computers that were in the very, what we'll call them like 4 megahertz, 4 million cycles per second, then 8 megahertz, and then 16 and 25 and 33 and 40 and 50 and 100 megahertz and 200 megahertz, 333, 500, 700, 800, 900, 1,000 megahertz, which is a gigahertz, and, all the way up to a little over 3 gigahertz for our central processing units today.
Right, 3.8 or so.
Yeah. Now and we're having trouble going faster than that. Now, my understanding is that we are limited in electronics by the speed of light, which is the speed of electricity, 186,000 miles per second. So if you want to go faster, if you want a faster computer, you've got to shorten the distances that those electrons have to move. In order to shorten the distances, you have to make the circuit traces closer and closer and closer together. But the closer together they are, the less real estate those circuit traces have to dissipate heat. So we have the problem of how small can we actually make these traces, or these wire paths, if you will, within the circuits, and how do we get rid of the heat? Aren't those the two problems that we have? And we've run into a problem where we can't seem to get them to go any closer or any faster because of the heat and our ability to make those distances smaller, and the separation between we'll call them wires, any smaller. Is that it?
Yeah, that's exactly right. The transistors, when they up the speed on these processors, that's where most of the technology and the research went into. And they put things closer and closer and closer and closer together, and they printed all of this stuff on one chip. The one chip, say the Intel chip in your current day computer running at 3.8 gigahertz, they not only have to put them closer together, but they have to use lower powered MOS, metal oxide semiconductor technology, CMOS and NMOS, all of those sort of things, to generate less heat, because the heat has to be carried away, and the circuit has to be kept cool enough, or these parts will literally burn up. And now on the current Intel chips, or the AMDs, whatever you got in your processor, you got a little chip that's about, 3 inches by 3 inches square, with hundreds and hundreds of contact points coming into a socket. If you would take that chip, which has literally millions and millions of transistors on it and components, some capacitors, resistors, diodes, if you would take that chip and make a circuit schematic of that chip to make it human readable, you would need a gymnasium to spread the paper out on the floor to be able to human read all the stuff in it.
And I took a CPU apart, and I looked at the actual circuitry within that package, which is, like the size of a large postage stamp. That CPU itself is probably about the size of a capital letter O on a typed 8.5 by 11 page. Lou Cassidy's with us, and we're talking about electronics and describing some of the history from the 1950s, 60s, and 70s. And Lou, we talked about the integrated circuit and these small packages and how the CPUs are getting smaller and smaller and smaller. And so is memory. So what we're doing is we're packing more devices, more capacitors, resistors, diodes, in a smaller and smaller space. And these traces are getting closer and closer together. And I guess now's the time when we should talk about an EMP, an electromagnetic pulse, and why an electromagnetic pulse can take out these devices, whereas that same electromagnetic pulse cannot take out a vacuum tube device, which is, physically much, much larger. Would you care to share any information about that?
Well, the EMP creates a large voltage, an instantaneous spike in voltage, and that is the big enemy of transistors, especially the newer stuff they're using, the CMOS and the MOS type technology. And these transistors and things they're putting on these circuit boards, to make them closer together and generate less heat, they're making them thinner and thinner and thinner to where they're just, maybe 10 atoms thick on some of these new transistors and stuff. And a voltage spike will blow a hole right through that, in no time flat. Even static discharge, you rub in your sweater or something like that will take one of these out, although they do have a diode protection on the input pins. But something like a spike, a massive spike, will just blow holes in all this and, makes junk out of it real quick.
Yeah, I remember when we were manufacturing computers back in the 90s, I would have a wrist strap on, with a static drain wire connected to a ground. So as I walked across the floor, that my clothing wouldn't generate static electricity, even in a minute amount. And if it did, it would be drained off by this. I was on a leash. It's really what it was. I was on a leash. My wrist was, there was a wristband, like you might get at a hospital, but it had conductivity, and it was attached to a thin wire that was connected to an alligator clip to a ground, and the static would be drained off me so that when I handled memory circuits, central processing units, motherboards, those kinds of things, that I wouldn't blow them just by the static electricity of my body. So the bottom line is that static is an enemy of advanced electronics, and the faster the processor is, the faster the electronics, the smaller the package, the greater the risk of being destroyed by an EMP or static electricity. So that's it in a nutshell.
Right, and a vacuum tube had space between the components in there in a vacuum, no oxygen, and these components were not semiconductors. They worked on boiling electrons off of a cathode to create an amplification or a switching circuit or something like that. And the tubes being spaced out like that in non-semiconductor are impervious. The spike won't hurt those at all.
Mm-hmm. Lou Cassidy, do you have any recommendations for the storage of electronics? Let's say people want to make sure that if there's an EMP that some of their devices may continue working. Do you have a recommendation for a Faraday-type cage for that, or just forget it?
Oh, no. I have I'm a ham radio operator. I have a lot of ham radio gear, and that's one of the things we do as hams is to protect that stuff in case of an EMP so that if communications goes down and everything's out, we can unpack our communications equipment, throw an antenna wire over a tree limb, and get up right away. So what I use for the EMP protection are metal ammo cans, and you can buy big ones that 50 cal comes in and all that with the 6 turnbuckles, snap-on lids and stuff. I take and I put the equipment separate it a little bit from the metal case, a small piece of cardboard or something in there, and you put the radio down in this and put the lid on it. And what I do, I put them in the basement. The basement will also shield somewhat against EMP. So a Faraday cage down in the basement is probably as safe as you're going to get. And I have a lot of radio gear and that kind of stuff. Shortwave radios, all kinds of stuff, cached in ammo cans, ammo boxes, bigger ones, down in the basement. And, if the worst should ever come about, you can pull that stuff out. And in fact, we go into multi-layer there, because if we get hit with an EMP and you bring out your emergency equipment, what happens if they go, we'll wait 2 weeks and give you another EMP and you blow out all that stuff? We have another layer of that stuff in more ammo cans down in the basement so that we can go through 2 or 3 EMP events and still be able to communicate.
Now, Lou, some people, you're talking about ham gear, and a lot of ham gear that is solid state will run on 12 volts, meaning 13.2 or 13.4 volt lead acid car battery, right? Now, some people may be wondering, well, what about the car battery? Is that going to survive an EMP?
Oh, yeah, it won't hurt a car battery. Car batteries will be impervious to that.
And what's your take on these new automobiles that are rolling off the line right now, these new shiny plastic enhanced vehicles, with plastic bumpers, plastic everywhere, with as many as, well, actually over 100 small processors that are networked on a bus to keep these cars comfortable. So you've got computers for the lighting, computers for the heating and air conditioning system, then you've got computers for the engine control, and then you've got computers to a little computer in the gas tank to tell you how much fuel you've got. I mean, all these computers are connected. Now, what about them in regards to an EMP? What would you expect if there were 100 cars on the road in front of you? What would happen? Do you have a feel for how many of them would still be working? Which ones would be working? Which ones would be destroyed, or would they all be working?
Well, the ones out in the wide open, if a pulse comes along, it's likely going to take out at least some of the circuitry in there, some of the computers. And even if the main computer is working and the engine runs, which is a maybe, then a lot of the other peripherals that report to this computer are not going to work, and you're going to be running a vehicle at reduced capacity, computer-wise and control and sensory-wise, if it runs at all, is the way I see it.
Okay. Let's talk about antennas, for example. Let's talk about antennas that we don't even think are antennas. For example, so I'm in the studio right now, and I have a set of headphones on. And the headphones are wired. So there's a wire, let's say, it's like 5 feet long. This wire has two conductors, and it has a jack on the end, and it's plugged into a headphone amplifier, which is connected to a microphone mixer, which is connected to a device that takes the signal and sends it off across the internet to Genesis Communications Network. Now, the reason I'm mentioning all this is there are several wires that connect our equipment. For example, let's start with the headphone, that 5 foot headphone wire. Lou Cassidy, would that in your world be considered an antenna that would collect the electromagnetic pulse if there were one? Just that piece of wire that I have as my headphone cable or wire. Oh,
that piece of wire will collect it. A coat hanger will collect it. A fork in your drawer will collect it, depending on the frequency of the pulse and all that stuff. Especially if you have a piece of wire that is resonant to that frequency or some multiple of that frequency, then that will even amplify the effect as being a resonant antenna. And yeah, even the cord plugging it into the wall becomes an antenna, and especially the wiring in your house is an antenna, and even more than that, the wires coming into your house going down the street and out that country road where you're at, all of that's an antenna, and anything plugged in when a pulse hits is going to have a big pulse on it, and if it's computerized, transistorized, it's liable to blow.
Okay, so class, think about this. As you go forward, if you want to protect your equipment, think about what it's plugged into. Okay? Think about the power cords, your power cords that run from your computer tower, if you want to have one of those, into your receptacle for electricity. That's an antenna. The cable that runs from your monitor to your computer, that's an antenna. The cable that runs from your mouse to your computer, that's an antenna. The wire that runs or cable that runs for your Ethernet to your network switch or your router, that's an antenna. All of your house wiring, as Lou just said, is an antenna, which is all connected to your circuit panel, which is connected to the grid, which on power poles is a massive antenna. So there's a lot of places for that massive pulse to jump on. All these antennas that are connected to you and your devices, or even your cell phone, if you're charging your cell phone, It's connected to the grid, which is connected to through a cable to charge your cell phone. And correct me if I'm wrong, Lou Cassidy, but electricity is lazy. It's looking for the fastest way, shortest way, quickest way to get to ground. Is that right?
The nearest place to complete the circuit in the ground. Well, you can think of this as something we're all familiar with as lightning strikes. And a lightning strike, you know how a lightning strike can get in. It'll come in through your phone line, through your electric lines. If it hits the house, it'll come in through your house wiring. And it's an act of God where that goes. I mean, it can go anywhere. And like you said, the shortest path to ground is what it's looking for.
Lou Cassidy, can we change directions a little bit from what we might have been considering talking about to how can we protect our homes from these large pulses? We'll call them surges. That's what the industry term is. How to protect our homes from surges. Class, just a quick heads up. I did a search on eBay, and you can buy on DVDs a collection of the popular magazines that Lou Cassidy and I have been talking about for a little less than $10 shipped. So, hundreds of them on a DVD. Now, it's not as convenient as the magazine, the paper versions, but yes, you can buy them. For example, Popular Electronics, I'm bringing it up right now, 378 of the magazines for about a little less than $10 shipped. So I'm not saying that I have not seen these. I have not opened them. I don't own them. I don't have any financial gain on this. I don't even know who the seller is. I'm just saying that it looks like it's available, and do your own homework if you're interested in doing the kind of reading that Lou Cassidy and I did years ago. Lou, so for those of us who want to protect our homes, let's say we have computers, let's say we have a microwave oven with a clock, let's say we have a dishwasher that has a computer control, or we have an oven that has a computer control clock, or we have other computer devices like a television or a DVD player or a Blu-ray player or whatever we have that's computer controlled, even our phone systems in our homes. How can we protect that equipment? What's the easiest, best value way to do it?
Well, of course, the best way is to have it in a Faraday shield unplugged. But the next best thing would be to have it sitting there on your counter, not plugged in. But if the equipment is plugged in, the only thing you have to depend on then would be some sort of surge protector. And like you have said before, you have a whole house surge protector. You can buy power strips with surge protectors, and most of the power strip type devices have a MOV on there, metal oxide varistor, that is a chemical, mechanical, electrical thing that will absorb a pulse, a spike, and if it's a big enough spike, it'll blow it out first time. If it's smaller spikes, it'll absorb those, and every time that it has a spike, a little bit of it's used up, and it degrades over time. Your whole house device, could help from a lightning hit or an EMP, any of those sort of things. But anything that's plugged in is fair game. I have ham radios that are plugged in and on all the time, and I call those my sacrificial radios because if something happens, those are just automatically blown up, and you just replace them with stuff you have cached.
Mm-hmm. And Lou, so what you can do, class, is you can get these surge protectors, and on the bottom of them, they have a rating. They'll say LN, LG, NG. That's line to ground, neutral to ground, and so forth. And there'll be a rating in voltage, and it may say 400V, may say 330V. And what that means is the voltage that it will stop that spike at. So, for example, a 400V is not it won't give you as much protection as a 330V. Lou, would you explain that, please?
Well, yeah, it rates on the voltage to where the device kicks in. The MOVs, if you buy a MOV to put on a circuit board or a protection circuit on a product, those will be rated at the voltage that they start conducting. Typically on 12, 9, 12, 6-volt appliances or circuits, we'll say a radio circuit or something. If you will typically use like a 28 to a 50-volt MOV on that to protect the AC power coming in. You would use probably at least 150-volt MOV to where it wouldn't start conducting until the voltage reached 150. And from that, it'll try to suppress everything from 150 on up and keep it from getting through. Mm-hmm. And is that music?
And the idea is, wow. That's it. Yeah, can you imagine? That was pretty fast, Lou Cassidy. Yeah. We need to go again and again. So, the idea is that you want to stop these surges from coming through. And if you have a lower threshold, that device is going to get beat up more. The surge device will get beat up more. Higher threshold, it will last longer, but it won't protect as much. That's it in a nutshell. Lou Cassidy, thanks so much for being with us. Class above all, honesty and integrity. What happens next is up to you.